Hello, welcome to EGN 3613. In previous sessions, we learned how to use the present worth analysis to decide of the project or the investment is accepted or not. In addition, we used the future worth criterion and returned that back to the present worth to judge our projects. In this session, we will discuss using the annual equivalent worth criterion to judge our projects. The annual equivalent criterion assists in measuring investment worth by determining the proper equal annual payments. To find the annual equivalent worth, we need to find the net present worth, then multiply that by the capital recovery factor, which is the A given P with interest I and number of periods N, which means that the annual equivalence of I is equal to the present worth that we just calculated multiplied by the factor. When evaluating a single project, if the annual equivalence for I is greater than 0, then we will accept that project. If it's equal to 0, we are indifferent, and if it's less than 0, then we will reject the investment. So if it's positive, we accept. If it's negative, we will reject the project. If we are comparing a service project, we choose the one with the least annual equivalence cost. So if we are talking about the money, gaining money, profit, then we choose the one with the positive and the largest amount. But if we are comparing services and we are trying to compare the cost, then I will choose the one with the least annual cost, Let's look at the following example. We have the cash flow of 15 at 0, 3.5 at 1, and then we have negative. So if we are assuming that this is positive, this is negative, or the other way around, whatever you feel like the payment. So if this is like into your pocket, this is out of your pocket, then those are the negatives and this is the positive. If it's the other way around, then you do it the other way around. But usually, like we said, we use the concept of in pocket and out of pocket for the positive and negative. So we have these values that are considered out, and this is in, and we would like to calculate the present worth. So I will bring all these values to the present to point 0, and since those are different values, then I will bring each one of them separately to year 0 or to point 0 and find the present worth. If we calculate the present worth, then it will be equal to 6.95, approximately $6.95, and that's the present worth with an interest of 15%. Once I have the present worth value at point 0, then I will use it to calculate the annual equivalence for the 6 years. Multiplying the present worth value by the factor will give me a 1.835 or $1.84 annuity, or equal payments over 6 periods, n equal to 6. Why do we need to use the annual worth analysis while we know that the project accepted or rejected by analyzing the present worth. Already we got the present worth in the previous sessions or previous chapters, and we talked about how you find the present worth and you judge the project if it's rejected or accepted, or the investment if it's rejected or accepted. So why do we need to find the annual worth analysis? You know, actually management and accounting prefer annual worth analysis since it helps in developing the annual report and yearly budget. So it helps in developing the annual report and yearly budget, and that's why they like that one. You know, when you have the yearly report and yearly budget, then you can find the annual cost or benefit from that report. So it will measure the investment worth on annual basis, which will help in the consistency of the annual report format and determining the unit cost or the unit profit, and it facilitates unequal project life comparison. If I have two projects that doesn't have equal life periods or number of periods, then this type of comparison, this type of analysis will assist in making the proper judgment. The annual equivalent worth also assists in the repeating cash flow cycles. We have the cycle being repeated again and again, and that will assist in calculating the cash flow for these cycles. Looking at the example that we have, the calculation for the two cycle. For the first cycle, we bring all the different cash flows value to the present, then calculate the annual equivalence for 5 years, and that will be $304.78. If we go back to the diagram, you can see that we can bring all these values back to 0, then calculate the net present worth for these values. One will be in positive, the other in negative, and you can find the value, and based on that you can find the annuity over 5 periods. What about both cycles? Now remember that we got the present worth as $1,155.68. So if we use this present worth multiplied by the factor, we got the annuity for 5 years. How about for the other period? Since we are bringing these values, all these values, back to year 5, finding the net present worth for these payments, now I will use that as future value and bring that future value back to year 0. And that what will happen here, that now this is considered as future, so I need to find the present value for this future value given f with 10% and over 5 periods and equal 5. Once I find that, I will add it to the actual present value for the first cycle. This is the first cycle, present worth for the first cycle, and the net present worth will be equal to $1,873.27. Using this new present worth to find the annual equivalence with 10% over 10 years or 10 periods, then it will equal to $304.78, which is the same value for the 5 years. So that will help, just finding the annual equivalence will help in determining the values for the cycles. If I found that for the cycle one, if it's repeating, then I don't need to recalculate again and again. I just can calculate it for the first cycle, and that will be for all the other cycles. It will be the same payment for all other cycles. Usually in project or in a company, we either look at the cost or the profit. The cost of the project or the profit coming from that project. Usually we are trying to either minimize the cost or maximize the profit. So with dealing with only costs, the annual equivalence method is called the annual equivalent cost, which includes operating cost and capital costs. Now when you say capital cost, that means the cost of buying land or maybe buying the building. It could be also the cost of constructing that building. It could be the cost of buying machines or equipments. That cost could be a combination of all three of them. So I could buy the land, build the building on that land, and then buy the machines that goes inside that building. And all that is an initial cost that will be considered as capital cost. There are two transactions associated with owning an equipment or a machine. Once you buy that machine, put it in that building, we have actually two transactions associated with that, or with being able to own that machine. The first transaction is the initial cost that you pay when you buy that piece of equipment. While the other transaction is the salvage value, which will happen at the end of that machine life cycle or at the end of the service. The initial cost is a present value, while the salvage cost is considered as a future value. Salvage is a future value because it happens in the future, while the initial cost is present value. So I is present here, while S is future value. Taking that into consideration, we can calculate the capital recovery cost using the formula. Capital recovery for I is the interest, will equal to the initial cost multiplied by A given P, which means that the initial cost is P. So that is the initial money that I spent to buy this equipment. It's present. It's today's money. Minus S multiplied by the factor, which is A given F. And that means that the salvage value here is considered as a future value with interest I and number of periods N. But remember that from chapter 2, that if I have future value, then that will equal to A given P with I, interest I, and number of period N minus I. So I can substitute that in here, and I will get the formula I multiplied by A given P with I and N minus S multiplied by A given P, I and N plus S multiplied by the interest I, or I multiplied by S. Taking the A given P I and n as a common factor here, this factor as common factor between the I and the s, I will get I minus s multiplied by the factor a given p with interest I and number of periods n plus I multiplied by the salvage value. And this will be my formula to find the capital cost. One of the questions that we love always to answer is, will your car hold its value? Once you buy a car from a dealer, it loses a lot of value, and you can see, after 3 years, how these prices goes down a lot. Although, you have a monthly lease payment that is high, but the value decreases. The value for the car decreases. So after these years, we can look at these values as salvage value after 3 years. Salvage value after the end of the 3 years. And these values differ from one brand to another. Let's look at the following example, which calculates the capital cost for a Mini Cooper, for example. If the initial cost was $19,800, over 3 years, n is equal to 3, the salvage value for that car, it went down to $12,078. If the interest rate is 6%, find the capital cost. Find the capital cost for that car. Now remember that at year 3 or point 3, the value is $12,078. So this is considered as the future value, which is in our case is the S. And I can bring that to point 0. While at point 0, which is the initial value, is $19,800. Using the formula that we just found or derived, we will find that the capital cost will equal to $3,613.55. This table shows the cost of owning a vehicle after leasing it for 3 years, assuming an interest rate of 6%. So the price after 3 years will equal to these values. In this example, or the example in this slide, actually justifies an investment based on annual equivalent analysis. If it was given that the initial cost is $20,000, this is what we initially bought the machine or the car or invested in, and the salvage value is $4,000. N is equal to 5 years and I is equal to 10%. Is it worth paying or getting $4,400 every year to recover that capital cost? Is it worth the $4,400, or should I pay less, or should I pay more? Since I have $4,000 salvage value, which is the future one, I can bring it to 0. We can calculate the initial cost with I equal to 10, N equal to 5. Using the formula, we'll find the capital cost. And the capital cost in this case, or the annuity, equals to $4,620.76, while we suggested paying only $4,400. So actually the $4,400 is not enough to cover the cost, the capital cost, for whatever machine or car that we paid for. Actually, we need $220.76 more just to be able to pay or recover the cost, or cover the capital cost for that machine. That will be all for the session. If you have any questions, you can email it through Falcon Online. Thank you and have a great day.